In addition to students developing their conceptual understanding and procedural skill of multi-digit multiplication, students will also develop their application skills through multiplicative comparison. In this video, we'll take a look at two anchor tasks that show how students develop that understanding and use it in increasingly complex ways throughout the unit. In Topic A, students first encounter multiplicative comparison word problems involving the three main situation types, including a larger unknown, smaller unknown, and unknown multiplier. During this introduction, the problems all involve computations within 100, so that the cognitive demand is on making sense of the new problem types rather than the computations. Let's take a look at Lesson 3 Target Task Problems 1 and 2. As you solve, consider how these situation types differ from one another, as well as how they differ from the situation type addressed by the post-unit assessment item number 2, which you looked at in the Standards Review section. Let's take a look at Problem 1 first. Students are told how many runs are scored in a baseball team season and that this is 9 times the number of runs scored in the first game. To solve, students might draw a tape diagram to represent the situation. Students might first ask themselves, which quantity is bigger? How can I draw a tape diagram to reflect the bigger quantity? Since the number of runs the team scored in the whole season is 9 times as many runs as they scored in the first game, they draw a large tape to represent the 72 runs for the season. Since this is 9 times as many runs as they scored in the first game, they draw a separate tape that is 1/9 as big as the tape they already drew and label their unknown, perhaps with a G. Then, students might represent the relationship with an equation, writing this as 9 times G equals 72. This can be rewritten to be 72 divided by 9 equals G, and thus there were 8 runs in the first game. In Problem 2, students are told how many grams of sugar are in a serving of strawberries, as well as how many grams of sugar are in a serving of strawberry ice cream, and are asked to find how many times as much sugar there is in the ice cream than in the berries. Again, they can draw a tape diagram to solve, drawing a tape to represent the number of grams of sugar in a serving of strawberries, and another longer tape to represent the number of grams of sugar in strawberry ice cream. In order to find how many times as much sugar is in the ice cream than in the berries, students must determine how many 7s are equal to 21. They can write this as an equation, perhaps 7 times t equals 21, where t represents the multiplicative relationship. Rewriting this to be 21 divided by 7 equals t, students see that there are 3 times as many grams of sugar in the ice cream as in the berries. While both problems are multiplicative comparison situations, they differ slightly in what they're asking students to figure out. Problem 1 represents a multiplicative comparison situation with a smaller unknown, and Problem 2 represents a multiplicative comparison situation with an unknown multiplier. By comparison, number 2 on the post-unit assessment is a multiplicative comparison situation with a larger unknown. These 3 tasks represent the 3 main types of multiplicative comparison situations. Note that you don't have to use these terms and categorizations with students, but using them or any other student-friendly term can help facilitate discussion about these kinds of problems. For example, students might discuss why multiplicative comparison problems with a smaller unknown are tricky, since the term times as many may lead them to believe the answer should be larger, when in fact it isn't. Any term will do, though, since these titles aren't precise mathematical vocabulary, but rather are just descriptions of the situations. Regardless of whether or not you use them with students, these terms are especially helpful from a pedagogical standpoint, allowing teachers to get a more nuanced understanding of what types of word problems students may need additional practice with. For more information on word problem types, see our Word Problem Teacher tool. Then, in Topic C at the end of the unit, students solve more complex multiplicative comparison problems, both in terms of the computations required and the number of steps involved in solving. Take a moment to read and solve Lesson 17's target task. As you solve, think about what makes this problem more complex than the ones we just looked at, as well as how it illustrates the distinction between additive and multiplicative comparison. In this task, students are asked to solve a more complex word problem. Since Denise has 4 times as many coins as Stan does, this part of the problem involves multiplicative comparison. Since Tyrell has 218 more coins than Denise does, this part of the problem involves additive comparison. Thus, students must be able to distinguish between additive comparison and multiplicative comparison in order to make sense of this problem. In order to solve, students again can draw a tape diagram. They draw a tape to represent the number of coins Stan has, 137. Since Denise has 4 times as many coins, they draw a tape that is 4 times as big as the tape they drew to represent Stan's coins. Next, since Tyrell has 218 more coins than Denise, they draw a bigger tape than Denise's and mark the additional length with the quantity 218. We can mark this final tape with a letter, such as T, to represent the unknown we're trying to solve for. Since students are asked to write an equation or equations to represent this quantity, they might first write an equation to represent the number of coins Denise has as 4 times 137 equals D, where D represents Denise's coins. Then, to represent Tyrell's coins, we can think of this as 218 more than Denise's coins, or 218 plus D. Or, students might choose to write just one condensed equation, thinking of the number of coins Tyrell has as 4 times 137 plus 218. While writing just one equation to represent this situation is desirable, it is not an explicit expectation that students do so for all problems they encounter, and certainly not the more complex ones. Thus, writing a single equation or more than one is acceptable. Then, to find the number of coins Tyrell has, students multiply 137 times 4 using the multiplication skills they just built over the previous 2 topics, and add 218 to arrive at a solution of 766 coins. This task, which comes towards the end of the unit, reflects a more advanced understanding of multiplicative comparison. While the tasks earlier in the unit were one-step word problems, this is a more advanced 2-step problem, involving a multiplicative compare situation and an additive compare one. Further, students must perform multi-digit multiplication to solve, a skill they've developed over the course of the unit. In the next unit, students will further develop their computational and word problem-solving skills as they study multi-digit division.